In this video, we are to estimate P using the maximum likelihood estimation for the geometric distribution. So we'll be finding a maximum likelihood estimator for the geometric distribution with parameter P. Solution. For more on this topic, you need to subscribe to this channel. The first thing to do, if we are to find the maximum likelihood estimator for any distribution, the first thing is to take the likelihood of that distribution. So, the first thing, given the geometric distribution, the first thing to do is to take the likelihood function of this. So take the likelihood function. The likelihood function of the given distribution written as this is equal to the product sum as running from 1 to n of that distribution, which is equal to, this is our distribution, the product sum as I running from 1 to n p into 1 minus p raised to the power of x minus 1. That means we are to find the likelihood function of I running from 1 to n, 1 minus p raised to the power of x minus 1. So this is the likelihood function we're looking for. Now, to get the likelihood function, as we said, is the product sum of the given distribution. How do we get the product sum? It means we have to take the product of this. Now, the product sum of this will give us, the first one is p into 1 minus p raised to the power of x1 then minus 1. This is p1 multiplied by p, this is the second p, 1 minus p raised to the power of x2 minus 1. Then it continues like that to give us p raised to the power of n, 1 minus p raised to the power of xi minus 1. So we get xi minus 1. This is what we get. It then means that we can write our likelihood function to be p raised to the power of n into 1 minus p raised to the power, because if you solve x, we get xi's. And okay, we will have something like this as I running from 1 to n, xi minus 1. Now we have to sum x and also sum 1, which means we can write our likelihood function to be p raised to the power of n into 1 minus p raised to the power of solution of xi's. If we sum x minus, if we sum 1 is a constant. So if we sum 1, we get n. So we will have n. This is what we get. We have succeeded in getting our likelihood function. The next thing to do in maximum likelihood estimator is to take the log function. So we write take the logarithm. Taking the logarithm, we have mean, take the logarithm of this. Mean of our likelihood function x p to be equal to, if you take the log of this from our logarithm, we have n ln p. Now, if we take the log of this, we have plus summation of xi minus n as I run from 1 to 10. We have this mean 1 minus p. So this is what we get. After taking this, after taking the logarithm, after finding the logarithm, the next thing to do is to differentiate with respect to that parameter p. So we differentiate with respect to p. So we write here. Take the derivative with respect to p. So we take the derivative with respect to p. If we take the derivative with respect to p, we now equate to whatever we get to 0. That is how we can find the estimate of p. So we move over to this side of the board to find the derivative of p. We move over to this side of the board. So how to do this? For more on this topic, you need to subscribe to this channel. So taking the derivative with respect to p, we write it this way. The derivative of mean likelihood of f of x, then p, divided by our derivative of p with respect to p. So now, if you differentiate this with respect to p, we have n all over p. That is what we get. So if you differentiate this with respect to p, this is what we get. We get plus summation of xi minus n as I running from 1 to n all over 1 minus p. Because we have negative p here, we multiply it by negative 1. If we differentiate this, if we differentiate the whole of this with respect to p, this is what we get. We get this. Of course, we can rewrite this properly. It give us n all over p. Because of this negative sign, we write here negative summation of xi minus n all over 1 minus p. So this from ideally from 1 to n. So the next thing to do for maximum likelihood estimator is to equate to 0. Equate to 0. What are we equating to 0? The whole of this. Whatever we got from our derivative. So we have n all over p minus summation of xi minus n all over 1 minus p as I running from 1 to n. So this is what we get equal to 0. Now, the next thing to do, we are to solve this. We have to solve this because it's now like an equation. So we'll solve this. We'll move over to this side of the board to do that. So for more on this topic, you need to subscribe to this channel. So this is how we can solve for the geometric, the maximum likelihood of the geometric distribution. So we have this. The next thing for me to do is to cross multiply. If you cross multiply, the left hand side of this equation, we'll have n into 1 minus p or let's simplify the left hand side. So to simplify the left hand side, we have n into 1 minus p minus P into summation of xi minus n as I running from 1 to n all over P into 1 minus P. Of course, nothing has changed. So now if we cross multiply, we see that this will multiply 0 to give 0. So the next thing for we to do is to open this. To open this, you have n multiplied by 1 is n. N multiplied by p is negative np. Now, minus p, negative p multiplied by this, you have p summation xi. I mean, negative p summation xi. Negative p multiplied by negative n, you have positive n p to be equal to 0. Of course, this is multiplying this to give us 0. So this is what we have. And if we watch out from here, we see that the whole of this can cancel the whole of this. So we have left with us n minus p summation of x to be equal to 0. Of course, this can be moved over to this side to give us n to be equal to p to come to positive summation of si as I running from 1 to n, as I running from 1 to n, as I running from 1 to n. So this is what we have. Now we can make p the subject. Once we make p the subject, p becomes the estimate. It becomes the maximum likelihood estimator for the geometric distribution. So we say make p the subject. So that becomes our p estimate will be equal to n all over summation of xi. Now, if you watch at this thing is the reciprocal of p. So it means that our p estimate is equal to 1 all over x bar. Of course, now our p estimate is biased for the maximum likelihood of the geometric distribution. So we can now simply write our p estimate. Our p estimate, if we want to write it here, our p estimates can be written here as p is equal to 1 all over x bar. So this becomes our maximum likelihood estimator for the geometric distribution. For more on this topic, you need to subscribe to this channel to get more videos on maximum likelihood estimator.